right, so this is part 2 of our SwiftUI Basics series, and it's just all the stuff that we need to kind of just get started and just kind of get dangerous with SwiftUI. And the second part of this I want to talk through is referred to as view sizing. And basically, the idea is if we don't have a fundamental understanding of how the size of a view is actually generated, we're going to have a lot of trouble working with SwiftUI. And actually, it's quite simple. But keep in mind that any view that we have in our program is a view that shows up on our display on our iPhone. So let's get started into view sizing. So this diagram should look familiar to you based on what you saw in part 1, where we actually did Hello World, a text view in the middle of our iPhone display. So over here is our iPhone display, or a representation of that. And then here's the code that would have come right out of Xcode when you did a new project. So we didn't have to write any code to get this far at least. And what I've added here is a couple of symbols which really show what's referred to as a view hierarchy. And a view hierarchy is just saying that we have views and then we have child views, if you will, that are subviews of that main view. So if you have a view and you have child views underneath it, and you're a child view, you have a parent view. So it's very much like you're a parent or a child, and children can become parents, and so parents have children and so forth. So this can be a hierarchy that's relatively deep. In this case, to start out with, I just want to start out with 2 levels. So the first thing to think about is that when we look at sizing, sizing is going to go through 3 steps. And the first step is going to be where the parent proposes a size to its child view. And that's what's going on and being represented right here. So here we have a content view, which really it just got its name from that struct. And basically, we're saying that parent view, the content view, represents the entire display of the iPhone. And so what it's going to do is it's going to propose a size to its children, whatever child view is there, and it's going to say, hey, you can take up the entire display of the iPhone if you want. And so that's the initial proposal of a size in this case. Now, secondly, then the child is going to say, well, thank you, but I really don't need that much room. Especially a text view as an example. A text view is going to be the type of view that says, I'm only going to take up as much space as I actually need to display the text that I need to display. So in this case, Hello World, in this example, we're saying it's 100 pixels wide by 20 pixels high. And so therefore, we're saying that the size of the text view only needs to be 100 by 20. And so even though it's saying thank you for the whole display size, I only need this amount, and that's what gets sent back up to the content view. And then the content view, or the parent view in this case, says, okay, I've got your size. I will put you out into the parent view space, and it will lay it out based on certain rules, which we won't cover now. But at this point, it's saying, well, I don't know where to put you, so I'll just put you right in the middle. So you're going to go right in the middle of the space that is associated with the parent. And that's actually the process. So again, the layout procedure is 3 steps. 1, the parent proposes a size to the child. Secondly, the child chooses a size and sends that size back. And then third, the parent will place the child in its coordinate space. So it's always those 3 steps that take place. Now, we're going to walk through this in a couple of examples, but I am going to repeat this and review this as we build up our UI so that it will become second nature to you and be something that's reinforced. So if you're thinking that, wow, this sounds really hard or complex, it really isn't. But when you're initially exposed to it, it can sound a little bit scary. So one other thing I want to show is that each view in that second step always chooses its own size. And as a child, it is the child that decides its size. The parent does not. The parent can propose a size, and the child may adopt that size, depending on the type of child view it is. But the child is the one that's going to decide the size, not the parent. And so that's another fundamental key concept to keep in mind. Now, the other thing about children is that child views have 3 different ways that they can adopt a size. One of them is to say that they refer to them as size neutral, which means I don't really care about the size. If you propose a size to me and I have children, I'm going to just send that size on down to the children. And by the way, if children report sizes back to me, I'm just going to send those back up the line as well. And that's what we refer to as a size neutral view. Now, the other 2 are a little more interesting. One is a child view may want to take up its entire space that it's given by the parent. So if the parent says, hey, you have this huge size or you have a size that you can use, the child might say, great, I will always take whatever you give me. I am going to use up that space. And so that is one type of view. And then the other type of view is the fixed size, which is what we have with text views as an example. And we'll see that with image views and so forth, where they're fixed sizes that are a size that it's going to report back to the parent almost independent of what the parent proposes. So let's take a little bit more complicated example. Again, from part 1, what we did is we had a view that had some padding in it, and it had the text in the middle, and it had a background color of yellow. And I'm just removing the foreground color of blue from the example because it doesn't add anything and it simplifies this a little bit. So when we look at this, we basically see a view hierarchy that looks like this. And this view hierarchy says this content view, which is the parent view, it's the root view, starts out, and then we have a child view called background. We have a child view for that called padding. And finally, we have a child view for that, which is the text view. So let's look at the process of how the sizing works when we walk through these views. So the first thing that happens is the parent says, wow, I have all this space, so I am going to propose to deliver all that space to the background view. Now, it turns out that the background view is one of those views that's size neutral, which means that it really doesn't care what size it's given. It's just going to pass it on to its child views. So it just passes that same size on down. Now it gets to the padding view. So the padding view accepts that full size, but says, you know what, for any children that I have, I am going to tell them that they have 10 points less on each side. So if they have 10 points less on each side, that's the new size that they will be given. And then the child can choose to adopt that size or set its own size. But the point is that the padding view took the full size that it got, shrunk it down by 10 points on each side, and proposes that new size, which is here, down to the children. So of course it gets down to the text view, and we already know that the text view is like, hey, thanks for that, but that's way more than I need. I only need 100 by 20 as the size of my text. So it sends that size back up to the padding view. And the padding view says, okay, that's cool. So now you're telling me you only need this size. I am going to add the padding that I'm supposed to do around you for 10 points on all 4 sides. So I'm going to report a size up from what you did that's going to be 20 points wider and 20 points higher than what you gave. That's what's going to come up to the background. So now the background gets this new 120 by 40, and the background says, hey, I'm size neutral, doesn't matter to me, but I do have another child view that is involved, which is the color. So this color is also a view, and colors just happen to be views that take up as much space as they're given. So they fall into that category where they're not neutral and they're not fixed. They're like, if you give it the whole display, it will take on the whole display. So in this case, background passes this dimension right here of 120 by 40 to color, and color says, great, I am going to return a view that is colored of the color that you've picked, and it will be the size of 120 by 40. So in our case, we picked yellow, so it's creating a view that's 120 by 40 yellow. And then finally, background sends the view back up to the content view saying, here's our new rendering, here's our new view, and it's 120 by 40. And then the parent view places it in the center, no different than it did before. And so that is the process that we go through when we are thinking about how things are sized with views in SwiftUI. So let's look at another example. So let's take, for example, a rectangle. And we can see here that we have the same code, the boilerplate code before, but instead of saying text, we said rectangle. And we didn't give it any dimensions or anything. We just say rectangle. And we see that we have the rectangle right here. So it's taken up the entire space. So if we think of different ways that a view can report size, remember one of them was it's size neutral. Another one was it will take up whatever size it's given. And the third was a fixed size. So which one do you think this rectangle is? So again, the question kind of to the students at this point is, of those three, and if they see the way this rectangle is constructed here, what type of view do they think it is? And the right answer for that would be that it is a view that will take up as much space as it's given. So I'm going to just turn this to blue just so it's a little nicer than that black square. And what is interesting about this is that the rectangle didn't take up the entire display. It only took up to a certain point at the top and the bottom. And that's because the parent view, when it gave a size to the rectangle and says, I propose a size of this, that was referred to as the safe area size. So the safe area is the area just below this area right here and just above this area right here. And the reason we have those on the iPhone is because there's actually icons up there such as your network provider and your wireless strength and battery levels and so forth. And down here at the bottom is the little bar that you swipe up on. So it has a little animation showing you how to do that. And you would not want, if you had a bunch of text here, you wouldn't want that text to be scrolling up in underneath all of the safe area. That's why the safe area is there. The safe area says if you're going to respect the safe area, then you don't have to worry about whatever you put there is not going to sort of collide with other icons and other things that are up here in the safe area. However, sometimes let's say it's just this blue rectangle and we want it to cover the whole thing. We don't want this white space here. Well, it turns out that we can add a modifier to our rectangle and we can say ignore the safe area. And if we say ignore safe area, then it takes on a new size, which is the full size of the display. Remember that a child view, which in this case is the rectangle, can take on any size it wants. But if it's going to take on a size that respects what the parent gave it, then it's either going to pick the safe area size or the parent is giving it the non-safe area size, which is the full size of the display. And with this modifier, that child view decides, I want to be the full display. And that's the size it sends back. So let's take another example, image. So image, we're just being introduced to this now, very much like text, except that the string that you put in here is the name of an image you have in your assets catalog. And I will show you the assets catalog when we get into Xcode and go through the example for all of this in code. But imagine at this point we have an image, which is, in this case, a constellation that you would see in the sky of stars. And this happens to be Orion. And so the constellation Orion is an image that's in our asset catalog, and it's called Orion. So when I say image here and put Orion, this is what is displayed. So the question I have is, do we think that the image is a view that gives us a fixed size or takes up all of the space in the display? The right answer is that it's fixed. Basically, it is giving back a fixed size where the image is just this big sitting there on the display. Now, there's an attribute we could put on here called resizable. And if I put on the resizable attribute, what we're saying is the child is not going to pick a fixed size. It's going to pick whatever the parent told it had available to it. So remember the parent saying, hey, you have the whole display. So because it's saying you have the whole display, the image is saying, great, I will take the whole display. And the reason it's answering the question that way is because of this modifier that was put onto the image. So now that we've done that, do we see anything odd about how this image is being represented on the display? And hopefully, as they think about it, it looks a little warped, right? I mean, it looks like it's skewed tall versus wide. And that's because when the image is rendered and sent up to the parent, it will have certain aspect ratios that it will try to obey or not. And so I want to just cover the aspect ratio real quick because it's really important with images. So let's look at the image in its normal form, right, where we haven't said resizable. And we basically see the image, and here we're saying that the image is 100 points wide by 150 points high. And so that's the size of the image. And because of this, there's a ratio of 2 to 3. So for every 2 points wide, it's 3 points high. And that aspect ratio, is what that's referred to, has to be held at any size that you do. Otherwise, it's going to look distorted. So, for example, if I want to make this 200 wide, question, how tall does it need to be to keep this 2 to 3 aspect ratio? Well, here we were 100 by 150. Now I've doubled this. So to keep everything even, I'm going to double this, and I'm going to go to 300. And so I've kept the aspect ratio the same as I have sized it up or down. So it's important to keep that in mind when you're thinking about images, is that you want to apply an aspect ratio where it says I'm going to stick to a specific aspect ratio, i.e. it could be the original aspect ratio of the image, which it usually is. Otherwise, your images, when they size up, will get distorted. The other thing to think about is as they size up, to grab that total parent size that the parent is giving it, there's 2 ways to do it. One way to do it is with a reference to fit. So here we have a modifier, and we're saying aspect ratio of .fit. What .fit does is it will size up the image just to the point where one edge, either the length side or the width side, hits the maximum size that the parent gave it. And as soon as it does, it's not going to size anymore, but it keeps the aspect ratio exactly the same. So what this does now is we have Orion sized to as big as we can make it, but to have it all still show on the display. So the thing to keep in mind here is .fit is something you will use a lot. Now, the other way to do this is .fill. So when you do .fill, this is how it looks in a .fill situation, where you're saying, I want the entire image to fill the entire display or the entire area that the parent has given me. And so fill can be useful. It's not useful in this particular case because we don't want to cut off parts of the constellation Orion. On the other hand, if it was, let's say, a photo of a grilled cheese sandwich, sizing it so that it kind of all fit, even though it cut off some of the table on the top and the bottom or whatever, as long as the grilled cheese sandwich still fit in the display, it might be just fine. So it's either .fit or .fill, and these are the 2 differences, right? Fit is going to size just wide enough or high enough until it can't go any farther, keeping the proper aspect ratio. Fill is going to go far enough so that it can completely fill in one direction or the other the entire display and keep the aspect ratio, which means some part of that may be cut off and sort of go outside the bounds of the display. So with that, let's jump into Xcode and take a look at how all this works in Xcode. All right, so here we are in Xcode, and this should look very familiar to you based on where we were on part 1. We only have our one view, which is put right in the middle, which is text, and that's showing over here, and we can actually see that border around the text view, hello world, which is hugging all of the spots on the text view, just keeping it to the size that it needs to show the text. So let's take that away and let's do the rectangle that we did in the slides. So if I type in rectangle, sure enough, here is a rectangle, and notice that the rectangle is taking up the entire display minus the safe area that we talked about at the top and the bottom. So again, the rectangle, what it's showing is that this is actually showing the space that the parent view said it could use. And rectangles are like, great, you tell me the space I can use, I am always going to take up whatever space you give to me. So what I'm going to do just to make this a little less ugly is let's just do that foreground color, and we'll do it as color dot, why don't we pick purple. And so now we have a purple rectangle that we're showing here, and we haven't taken up the safe area yet. Now, as we talked about, the parent is sending two sizes down. It's sending down the normal area, which is the safe area, and then it's sending down the size that includes the safe area. And so we can have the rectangle say, you know what, I'm not obeying the safe area, I want the full size. So we can add the dot edges ignore safe area to all. And when we've done that, notice now we've got this nice purple rectangle taking up the entire space or the entire view. All right, so now let's look at images. So we'll take this out. So I'm going to type in image, and I'm going to type in Orion. And we can see that we now have no compiler errors, and we have a view over here, which is a child view of this parent view, and look at how it's sized. You know, that's the size of this particular image that we have provided in the assets catalog. So let me just show you where that is. If I look over here on the left where you should have this menu showing all of your files, you'll see an assets.xc assets folder. And if I click into there, in this particular build that I've done, I have this constellations directory with a bunch of different constellation images in it. And so here's Orion. And basically whatever name is being given here is the name that we're going to want to use in our code. So for example, here's another one that says Libra. So we could go back here to our code, and I could type in here Libra. And when we do that, we now get that constellation, or we get that image. Also keep in mind, these are case sensitive. So even though it has a capital in the name, if I say lowercase l, it doesn't find it, then it won't show it at all. So it's not returning any size, and it's not returning an image. So let's go back to Orion. And remember that we said that if we wanted to take up the entire space that the parent is giving us, that we could use an attribute on the image called resizable. So if I do this and I say resizable like this, then now what that's saying is that we can take on whatever size the parent is saying we're allowed to have. And since the parent is saying you can have the whole space, that's what the image is saying that it's going to do. Also, keep in mind, the child views are the ones that determine the size, not the parent. The parent proposes a size, but it's the child that has to decide whether they're going to adopt it or not. So in this case, by adding this modifier on it, we've adopted the fact that we are going to take up all the space that you're giving us. So the next thing we could think about is, well, this obviously clearly didn't obey an aspect ratio. This clearly stretched it to be taller. So to fix this, we're going to add an aspect ratio modifier that tells it we want it to be fit. Remember, there was fit and fill. And so fit, I think, will be perfect because it'll fit it left and right the way we want it, but then it won't adjust the height any different than the aspect ratio says it should be. So we could say dot aspect ratio, and then the content mode is the method that we want to pick on that. And we can say dot fit. And sure enough, now look at this. We've got an image that's sized up to take over the whole size. And by the way, these dots and stars aren't going all the way to the end because there's actually in the image itself, there is white space. And we can tell that by if I click on the image here, we see the blue line going around. That is showing the size of the image itself. And it just so happens that this image has white space in it. And so that's how it is sized to this particular view. Now, if we say fill, this is where it's going to go as big as possible. So it's taking the top and the bottom and saying when it finally could hit those edges, even though it's holding the aspect ratio the same, what we see is not distorted in any way, but there are going to be sections of the image off on the left and right sides that won't be seen. So what we've done is shown basically how view sizing is working. We've looked at the rectangle and we've looked at the image. And what we're going to do in part 3 is look at how we can put a bunch of these things together to create a more interesting display.